Good day everyone. Today I will be talking about TC Macro Standard Operation Protocol as a supplementary data for my publication titled TC Macro, a simple and robust ImageJ method for automated measurement of tail coiling activity and zebrafish. So this is a brief introduction for TC Macro. This tail coiling macro or TC Macro is a macro meant for extracting tail coiling data from zebrafish larvae. So we use three tools in this method, which are VirtualDub2, ImageJ-based, and Microsoft Excel. This tool is oriented towards customizability to use in different setups. So these are the download links for the essential softwares to use with this tool. So the first one is VirtualDub2, ImageJ-based, and the plugins that is necessary to use the macro. And the last one is the Microsoft Excel, which can be purchased from Microsoft website. So this is the workflow for TC Macro. So first, we do a batch video conversion using VirtualDub2 to convert the video file to .avi for use in ImageJ. Next, in ImageJ, there are three processes, which are image processing, image thresholding, and array selection, and the last one is the data collection. So after we get the results from ImageJ, it will be exported to .excel file, and it can be used for data processing, final data processing in the Microsoft Excel. To convert the video using VirtualDub2, first you need to open the VirtualDub and navigate to File, Queue Batch Operation, and Batch Wizard. After you click on the Batch Wizard, it will open a new window where you can drag your video that you want to convert here, and the location of the file, the output location of the file. And then you can click on Add to Queue and resave in AVI format to save it in AVI format. After that, you click OK to close the wizard and continue with the next process. And next, we open Job Control, File, Job Control here, File, Job Control, or you can also press F4 as a shortcut. After you open the Job Control, you can click Start to start the conversion process. It will be exported in AVI file at the targeted location of your choice. In this step, we do image processing in ImageJ. So first, we open the image and run the macro, which will convert image tag or video to 8-bit or black and white color, and renaming it to working. Renaming the file to working, I mean. And here is the macro strings, and it also included the preset value for whole circle transformation. And next, the user are prompted to select the diameter of the egg. This is the diameter of the egg that we have, which will be calculated for whole circle transformation for automatic array selection. And after we select the diameter, we can select OK. And next, the second string of macro will calculate the radius of the egg, and the radius will be divided into suggested min radius or min r and suggested max radius or max r, which are 0.45 and 0.7 times the length of the diameter respectively. Whole score threshold value can also be adjusted from 0 to 1 according to the egg circularity and image quality. So in this case, the higher threshold value will mean that the egg is more circular. So if you have the egg that is more oval shaped or not circular, you should reduce the whole score threshold value. And here, the values in red is recommended value, but it can be adjusted according to the user themselves. Afterwards, we apply Gaussian blur and do fine edges to filter the edges of the eggs. Because the whole circle transformation algorithm, we need good good quality egg border for the algorithm to work. But as I mentioned previously, in the whole score threshold, if we reduce the score threshold, it will reduce the sensitivity of the whole circle transformation itself. So if your egg is not fully circle shaped or even has missing edges, it will be fine. And we do the threshold in the picture to obtain the suitable image for whole circle transformation. But for more information and more in-depth explanation of whole circle transformation, you can access Thales and Korting video on YouTube. Here's the link of the YouTube that I put in the PPT. So this value in red are also can be adjusted according to your preference, but this is the recommended value that we have. Whole score threshold depends on the filtered image rather than the original one. So therefore, it is necessary to do some trial to find the most suitable value with the recording or image quality and the settings for the image filter. And the unsuitable result will result to missing detection or false detection. And I will have the example for the missing and false detection in the next slides. So this is the unfiltered image before image processing. And this is the result of the image processing macro. So the filtered image is here on the left, while the centroid image is here on the right. So the centroid will be used to do the whole threshold automatic array selection, because they have different colors here. And by using the threshold tool in the ImageJ, it will select all of them based on their color, and then it will be saved in the ROI manager, and it will be used for Z projection of the ROI to see the intensity changes related to time. So this is the original filtered image, the same as the last one, but this is a bigger one, so I can show you a better here. And this is the result if you use 0.5 whole score threshold. So here there are a lot of falsely detected eggs due to low whole score threshold. So here, like in the number 25, is a fake eggs. Like there's a round area, but there's no eggs here. But it's caused by the eggs from the 4x that is number 21, 13, 3, and also this one that's not being detected as well. Here another example is also number 28. It's caused by the number 9, 2, 6, and 8. Also on the number 29, 40, 32, and number here 35 is also errors. So if you set the whole score threshold value too low, this will happen. And next, we increase the whole score threshold value to 0.7. So at 0.7 whole score threshold value, most of the eggs are detected without false detection. However, because like several eggs doesn't have a full zebrafish egg like area here, the edges, they didn't get selected here because the whole score threshold value is the 0.7. But here, in several cases like this one, number 37, it's selected here, but here it's not selected. So it has their positive and negative benefit of each whole score threshold. So here we also tried the 0.9 whole score threshold, but as you can see here that there's not a lot of X that are being detected, only 4 X here. It's because that most of them doesn't reach the 0.9 circularity of the whole score threshold, therefore they are not selected. So in summary, that the best value for whole score threshold is 0.7 in our example, and this result varies depending on the image or filtering quality, so it depends on the age. So if you have a really good image or video and the filtering quality is already good, you can set to 0.9 and it will be okay, and it will select everything perfectly. But here in our case, because there are some eggs that are not fully circular because of the edges are not too defined in the video, even after filtering, so 0.7 is the best. and it will also reduce the errors. And in summary, as can be seen on our example, the detection is by no means perfect, as there are several eggs remain undetected on the optimal threshold value due to its circularity, as I mentioned before. The next step is the image thresholding and array selection macro. So in this step, first we threshold the centroid map obtained from previous step and do measurement to obtain the maximal pixel value. Here's the maximal pixel value, which is 17 in this case, and it is the same as the number of the detected objects due to the different color used to mark each object in the centroid map. So due to the result of the centroid map that results in several different colors, we can use it to do thresholding, and it will also show in the measurement the number of the total eggs that it detected. Next, using the thresholding, we set the macro to detect all objects according to the user-defined size. In this case, we set to 500 to infinity. So the size of the pixel should be around 500 to infinity, and then saving it to array manager. So because we have 17 eggs detected from here, because there are 17 eggs, so it will do 17 different threshold value, and it will save it into array manager. So here the array manager, the first one 0001-0433 is the first one here, and it continues until it detected 17 times. After we obtain the stack difference images, we use plot z-axis profile tool from ImageJ in order to do z projection. In this z projection, we will obtain a curve which has time as its x-axis and gray value or intensity as its y-axis, which is related to the tail coiling events. And you can see here that there's several peaks. Each peak means that there are tail coiling that happens at that time. So to extract the events, we use the Find Peaks tool from the bar plugin, and it will mark the maxima of each peaks, which shows that how many tail coiling events that happen. And here's the macro, which also be included. Finally, the data will be extracted from the plot using the bar plugin. The detected tail coiling event is presented by x1 here. The extracted data are saved to predetermined location by the user, making new sheets for each ROI. So if you have 17 ROI, you will have 17 sheets. And the command will loop for each ROI according to the max value obtained in the previous step. I mean, by the max value obtained in the previous step is the max value in the measure step on the centroid map. So the string marked with blue here must be adjusted to according to the user system. So here for the example, we saved the file in the desktop as tailcoiling.xlsx. But please remember to rename the file before processing another video, or the process video will not save. This is the recording setup that we use for large-scale detection. So it uses a CCD camera connected to a microscope at 6 to 60 times magnification and a monitor for display. And the lighting is set for dark field microscopy to create a better contrast between ROI and background. So this overall step is the same as the last one, but using this setup we can record a lot more eggs at once. However, we found a problem in this recording setup because there are egg movements caused by tail coiling. So here in the example, this is the video start that we use as the base for the automatic array selection. And we see that the selection is very good and is very beautiful. But in the end of the video, if there are tail coiling activity, as we see here in the red circles, there are movement of the eggs that make them move out of the selection area. Therefore, we tested several methods to prevent this movement. To prevent egg movement, we created a wall surrounding zebrafish eggs using agar roast, and by increasing the solution viscosity using methylcellulose. And we tested two different diameter of agar roast wall at 8.5 mm and 4.5 mm, and two different methylcellulose concentration at 1% and 0.5%. So here is the result of our test. So at bigger agar roast diameter, it seems that there are still egg movement, a lot of egg movement, but in the smaller diameter of agar roast, there's less movement. But it's because the agar roast at 4.5 mm of diameter is the eggs here are tightly packed. Therefore, they cannot move too much, except like several of the eggs that are above the others. And the result of our methylcellulose test show there's also less movement in 1% of methylcellulose and 0.5%, but in the 1%, because the solution is too viscous, it created a layered effect for the eggs. Therefore, there are lots of eggs that are on top of each other, even it's not directly on top. So from this result, we recommend using methylcellulose at 0.5% for preventing egg movement. But if you have lots of eggs, you can use the agar roast method. The conclusion of our trial result is using methylcellulose at 0.5% is the best method for preventing egg movement. However, methylcellulose viscosity might change depending on the temperature. Therefore, it must be applied just before the recording process. And for agar roast, it is also a good alternative for recording as long as the number of eggs or area size are adjusted so that the area will be fully filled with minimal hollow space between the eggs, and it will prevent the egg movement because they are tightly packed. The final processes are done in Microsoft Excel. In this example, we have 5 sheets of Excel file. So there are 5 ROIs processed from the example. And in the first ROI, we found that there are 3 coiling events and 3 different max intensity according to the coiling events. And to calculate the coiling events, we only need the X1, but the Y1 will represent the max intensity during the coiling movement. And for the coil duration and interval between coiling must be calculated manually or by macro. And here we provide the Excel Vba macro to obtain all the data and make a simple summary from the data. These are the contents we provide in this SOP for data processing in Excel Visual Basic of Application or the VBA. So the tutorial includes the enabling Excel VBA, installing and copying the macro, and using the macro and troubleshooting. First, we need to enable Visual Basic of Application in Excel. To enable it, first we open File, Options, and click on Customize Ribbon and tick the developer box. So after we click on File and Options, this window will open, and we click on the Customize ribbon and tick the developer box. And then we click OK, and we are able to use the VBA. Next, we can open the VBA by clicking Visual Basic option here in the Developer tab and Visual Basic, or by using shortcut using Alt and F11. To create a macro in VBA, first we need to create a module by right-clicking the name of the project currently open on the left side here, and choose Insert and Module, and it will insert a module like this one. And afterwards, we copy the macro that we already provided to here in the empty module sheet. So here you see that there are several macro included that are already copied from our macro in the text file. And to operate the module, you have several buttons here to control whether or not you want to run the macro, pause the macro, or stop the macro. So each macro is divided with n substring and a line after ending a sub and creating a new one. So here there's end sub. After you create a new one, it will have this line. And to execute the macro, just click the macro that you want to run. For example, if you want to run the macro here, we just click here and click on the run macro or press F5. The Excel Vba macro that we provided is divided into three main parts or sub. The first one is process ITV endure for obtaining coiling interval and duration. The second one is for manual editing to edit the value obtained from interval and duration and for checking errors. And the last one is data extraction to extract the data for several endpoints. So the endpoints are written here: the tail coiling count, intensity, duration, and the interval between each tail coiling. And the value obtained for tail coiling count is coiling frequency or TC per minute, while the other parameters are the average of each value, average intensity, average duration, and average interval. But for the frequency, you need to change the macro a little bit depending on the length of your video. This is the workflow for our Excel Vba process. So first you open the Excel file and as before, we enable the developer mode and insert the module, copy the macro to the new module. And first we run the first macro, the process ITV endure, and we will obtain the interval and duration of each tail coiling activity. And afterwards, we check for errors within the data and adjust the parameter for manual editing and run the command manual editing. And the last one is we run the data extraction to get the summary for each RY or fish embryo. This is the logic we use for duration and interval calculation. So here we use the threshold to determine the start and the end of a coil duration, while the gaps between coiling are categorized as interval. So here, for the duration is here from the start until the end. So the start we set by the increase of intensity, and the end is when the intensity value or the gray value went back to the noise value. The value went down to the noise value. So the start and the end threshold might differ from each recording setup, and there are possible errors caused by recording noises. So if you have severe recording noises, then you need to set the start threshold to be higher. The first macro is process ITV endure. In this macro, we will obtain the interval between coiling activity and duration of coiling activity. So in this example, we have one interval and one duration value here. However, because there is only one occurrence of tail coiling, the interval here must be null in the process because there are no two coiling activity that we can say as an interval. Afterwards, we do manual editing for possible errors caused by settings or noise levels. So as mentioned previously, the first macro will start counting if the value change is higher than 3, which is the start threshold, and stop counting if it reaches the median or the end threshold. And this value sometimes does not match with the initial result, therefore it needed to be changed. Here we put several troubleshooting for manual editing. For the first one, if the counting did not stop at the end, and this case will happen if the end threshold value is too low. Therefore, increasing the value will solve the problem. So for easier observation, the x1 value, the count of x1 here is 4. It should be the same as the duration here. So if the x1 has 4 counts, the duration should also have 4 counts. So here, for this example, that there are only 3 of the duration because the end threshold value is too low. So here, this should be the first peak, second peak, third peak, and fourth peak. But because the end threshold is too low, it is the third and the fourth peak is counted as 1 here. So the duration is really high. But if we increase the value to average value from median value, it will change the number of peaks to 4, and the duration will also change. Therefore, we will have 4 durations here, the same as the peaks that we have here. The second error is caused if the counting stops prematurely. So in this case, the end threshold value is too high, therefore it needs to be decreased. So like before the example, the average value has a higher value. The average has higher value compared to the median. Therefore, if you use average as your baseline, then you should change it to median, or even change it to quartile 1 if there's lots of tail coiling activity. Or you can change the calculation function to the one with lower value result. You can just time the median or average value, like time it with 0.95 or 0.98 to get a better result. And the next troubleshooting is if the counting did not start. So in this case, the value for start threshold is too high because we set it at 3. But in several cases, maybe you need to decrease it to 2 or 1. It is depending on your video. So first you must optimize the value for the start threshold before you do several recording. And to summarize the data, we provided another macro which is called the data extraction. In this macro, it will collect the TC count, intensity, interval, and duration data into each sheet and create a summary sheet based on all the data. And in the summary sheet, the TC count will be presented as coiling frequency or TC per minute, while the other data are presented as respective average. And this is the results. So if the TC here is because our video is recorded for 30 seconds, then the TC count here will be timed by 2 for the TC frequency, but for the coiling intensity, interval, and coil duration is just the average of all the obtained data. In conclusion, we provided a standard operation protocol for a TC macro method for tail coiling. And we also provided the exact steps and the macro for both ImageJ and Excel Vba for those interested in using this tool. Users can fine adjust several parameters according to their needs, as we presented in the PPT. And the tool that we provided is a simple and versatile ImageJ-based method to provide new ways and idea for early zebrafish spontaneous movement data collection. It can be applied for neurotoxicity study in zebrafish. Next, I will provide a tutorial for using ImageJ and Excel Vba.